Welcome to a new test and teardown video. Well, this time it's going to be a let's repair stuff kind of a start, because this one don't work, and I kind of knew it was not working. It was supposed to be thrown out many years ago, but it just didn't happen, so now it's mine to fix. But this is a Hameg mainframe, the HM8001-2 mainframe and power supply unit. And for this mainframe you can plug in different modules. I got the HM8027 distortion meter plug-in module to plug in the left section. Well, I can of course put it in the right if I want to. And here it goes. It plugs in here, and there isn't any screws or any way this module is secured. It just slides in and then sits quite firmly here, because there's a good grounding connector here to the chassis, so that is really well made. And then there is this low distortion generator, HM8037. And that is a sine wave generator with very impressive low distortion specifications. And this one, see, there's a missing screw. And I think I know what is going on here, but we'll talk about that in a second. I think this is part of the problem. We got some liquids. That is this coming from the inside or is this coming from the outside? I mean, this can't be good. And then to open this, you need to remove this rear plastic part, and that was this one. And then you slide out, the entire cover is in one piece, and then you can see the mainframe unit. It consists of two individual power supplies, fully regulated and filtered and all that kind of stuff. Of course, this is super important when you're having very high and impressive performance on those two analog units. And I think this one was repaired, and again, I always find those permanent markers. I think it's the capacitors. I think we got the leak from over here, and if you look a little bit careful, you can see some splat around everywhere here, and it's been soaking around and out here. Of course, this one was probably defect like 20 years ago or 10 years ago, and then it was never repaired. It was just thrown out on a shelf, and then now I will try and see if I can fix this. It is quite nasty all over the place. We got some sticky stuff going on here, but I think it's mostly the generator power supply. But I will definitely clean up all of it and just change the 3 capacitors in each side. Let's see if those capacitors, they were changed before. Nope, they have never been changed, or so it seems. I mean, ooh, there's one was changed, right? Or at least resoldered, because that one out there is that one, and that is exactly the same. No, it is not. That one is different. Okay, see, that could be a hint, but definitely I want to change those capacitors, clean it up, and hopefully I don't know. But I kind of like this mainframe system. It's very simple. It's running off plus minus 12 volts and plus minus 5. The mainframe can actually support all sorts of different plug-in modules, and they're mostly sold with that with those plug-in modules that you wanted. So here is how it works. Normally there's a 5 volt module, and then there's a variable 5 to 20, and then there's another one 5 to 20, and they are completely individual. So what you can do is adjust this for 12, adjust this for 12, and then 5, and this is exactly what we need for the 2 modules we got. So I'll of course double check voltages and ripple and all that kind of stuff. Yeah, I think I was right. Can you see? Sticky, nasty capacitor puke all over the place here. And if I look a little bit more careful, this capacitor here is definitely not nice and cleaner and stuff. So I just need to go and get some new capacitors, and then we can get going after I've super cleaned everything here. So now the most dirty of the power supplies is now nicely cleaned. And of course I was playing lazy and was only looking at the big capacitors, but I mean, let me tell you, do you think large capacitors or small capacitors causes the biggest or the smallest problems in a product? Let me tell you, the smallest capacitors cause more problems, more work, because there are just many more of them, and it takes just a lot more time to fool around with smaller capacitors. Big ones, super easy to spot and super easy to replace. But I'm gonna replace all of them, because they are all of them from what, 91 or something like that, so that's quite a lot of years. Okay, the PCB was also quite nasty here on the bottom side. I've been trying to clean it up a little bit, and I removed this plastic isolation here, and then I can more clearly see what is going on here as well. Really bad corrosion around those screws. I don't know exactly why it is looking this bad. Oh no, this can't be good. What is going on here? That is nasty. There's actually one extra thing I want to show you. See, this is the power supply with the most puked up capacitors, right? See this center regulator? Let's go around here and have a little look. I don't know if I can show you this on the camera, but can you see the solderings? Yeah. This can't be good. This is looking like some of them got a very random contact. I need to clean all this up and add new solder here. I'm also trying to get access to that last capacitor in here. That one. This is driving me a little bit nuts. So I need to remove all this to access those 2 pads down there. Hey, how annoying is this? I need to show you this little funny thing here. So that is one of the large capacitors and one of the large. See, there are also smaller capacitors I showed you from the other side, right? So here's the small one and here's the small one. At least there's a thick track to that one, but here, see, a long thin track to a tiny little capacitor. What exactly is this doing in parallel to a big fat one that is really, really good? It's actually done correctly here on the outputs. See here, everything goes through that tiny little capacitor, so that is good. It's done correctly on all three outputs. But here, I mean, really, that is a little bit funny. So this is on the input with the high ripple. So all the high ripple current goes through that capacitor. See? And then stuff is taken from that point. So that is correct so far. So that looks a lot better. I am now completely done. And it looks more or less like brand new. Brand new caps and all. Super duper deep clean and all. And now all this disgusting slimo capacitor puke is completely gone. And I can start powering this up. But it's just one last thing to do. Look at those grounding connectors. They're super, super gross. Let's look a little bit into the other module plugins here. So this is the low distortion generator. And this one also looks like there's a little bit of nasty on that one. There's a funny thing about this one. There is a screw missing. So this tells me maybe something is funny in here. Ooh, yo. Yeah, we got a little bit of pukey puke going on in here. What the heck is this? Wait, look at that. This is... this is not good. It looks... this right there looks like the remains of a blown up capacitor. So that's probably why one of these two are looking different. And this one is a little bit swollen on the top. So this is probably the original. And this one was replaced. See, this is nice and flat in the top. I think I have reverse figured out what is going on here. So that is a blown up capacitor. Definitely, if you look at that little part here. So what we see here on that PCB is capacitor puke. I need to clean up, and there's another one I most likely need to replace as well. But other than that, I don't know what to say about this. That is probably because of the switches, so when you push them they kind of move, or to give a more... Yes, I can see that now. Look. I mean, why? How about we just remove this? What is the idea here? They are okay. I think I know what's going on here. This is contact cleaner, prevent from flying all over the place. So those contacts, they were cleaned. We don't want this contact cleaning to fly all over the place. I think that was the thing, and it was forgotten. It was simply forgotten in here. You can even see a little bit of green funky stuff here. Well, we don't want that in here anymore, do we? So all I have to do is clean up all this stuff and change this one capacitor. I think then this is power supply entry panel. Yes. So this is all there is to it. And yes, it is from 93. This is definitely a little bit nasty. Oops. Can't see anything. What is that? Yeah. This can't be good. Any more funny stuff? No way. And I like it, all the ICs there in socket. So here is your low distortion sine wave oscillator. How is that made? With just an op amp and some, that'll be the different ranges. Ooh, we got a little. Is that a super nice dual fed thingy? But other than that, it's not looking super crazy like I thought it would be. So after a lot of cleaning, it is now looking a lot better. Oh yeah, about those 3 switches. If you look at this, you can see that this switch was normally the grounding, but now it is another -20. Isn't that a little bit interesting? And here is what happened. There's a little modification done here. A little extra attenuator. So, it is a very beautiful single-sided PCB. And the interconnect to the 7-segment display is also done really nice and neat. No connectors or flat cables or funky stuff. Just a PCB up the other PCB and solder, done deal. And what you see here, that will be the display or the 7-segment decoder, because this is of course multiplexed. And then we got all the multiplexer circuits and stuff right here to do all that kind of things. Oh, there was actually one more thing I needed to add to the low distortion generator, and that is the test points. See, -15, +15, and then +5. See, that's the voltage requirements for this unit. Other units could be different, because it's actually normally ±12. But this one is 15. Let's look a little bit inside the distortion meter. I just cleaned up a little bit here on the front. I leave this 60 Hertz marker here. I think that's funny. Well, the board also is very dirty. And I think it is the sticky slime from contact cleaning that is causing the problem inside this one. And then all sorts of dirt, and then humidity sticks to it. I don't really see any kind of broken capacitors, but I see some funny dust, dirt, not so nice. I'm a little bit worried about how clean that IC is there. I don't know if you can see the socket is just full of corrosion and nasty stuff. This can't be good. I need to clean that socket, and the other socket here is also a little bit like that. But other than that, it's a beautiful design. So that's the readout, and down there will be the LED driver multiplexer IC. So that's all there is to say about this. I think that one is a RMS to DC converter, right? So that is how it's doing the readout. The PCB layout is a single layer PCB layout, but I don't know if you can see those dots. That's some sort of a nasty corrosion, and it's just all over the place here. It is really, really disgusting. Can you see that here? Yeah, this kind of light is good for that. Definitely I need to clean all this away. This can't be good. But I think my main problem was ripple on the power supplies. So that's of course causing these to be completely unstable. I don't see any local regulators or anything here, so everything here is just completely analog, right? So if power supplies are not nice and clean, yeah, of course you're gonna get flickering, funky, unstable readout, right? So I think I am ready to power this up. 11 watts, so that is actually normal. Let's just see if that switch is working good. Oh yeah, of course you need to take the output. So 5 kilo. See, I'm going for 1 kilohertz just to make it simple, right? So if the generator is delivering 1 kilohertz as accurate as I can. Ooh, that is. Of course, it don't need to be super accurate, but it's. So this output goes here into this input. And then we go in 100% cal. And then we just why? Yeah, okay, I understand why. You need to be in the right frequency range, of course. So this is the 2K range, and then this is important. Those two LEDs, they need to turn off, right? And then we are in calibrate 100%. So all we have to do is go for 100%. So this is the distortion level, and then we read distortion. So here is 100% full range, 10% full range, and then it should, yes, it goes to 0. So that means now we have a ripple-free, nice and clean supply, and everything seems to be working, at least at 1 kilohertz. So I'm actually quite happy about this. How about we try another signal generator and see if it's the same readout here? That could be interesting, right? So now I just take my signal generator, and all I did was go into calibrate here. I don't want to charge any settings here, just to be fair. So now I'm adjusting the level of my generator to deliver 100%. So that means everything else is exactly the same. And then I go to a readout. Ooh, isn't that typical? And I kind of knew that. And this is because my new super sexy Sigland generator is not a low distortion generator. No, it is not. But that one is. That is so funny. Let's try and do exactly the same with another signal generator. This is an all analog, and I have adjusted again calibration here, and then the level for 100%, and then the frequency here. I can actually show you. See what happens. It is quite a nice catch range for the frequency adjustment. So all that is fine. So let's try and read the distortion of that one. So here is 10% full range, and that is 0.04. Yeah, that is all I wanted to say. Thank you very much for watching, and see you soon again. Bye bye.